Hi guys, thank you all for joining this presentation on leveraging industrial IoT platforms for business success. This presentation was designed to hopefully give you guys a better understanding into what exactly industrial IoT platforms are, what the ecosystem is like, and how, companies are using them to achieve business success, because, industrial IoT platforms are quite hot now in the market. So before I proceed, I would like to also introduce myself. You guys must be wondering who on earth I am. My name is Daniel Stephen. I am an industrial IoT analyst for IoT One. And IoT One, we are an information platform. I aim to keep the presentation hopefully as bite-sized and short and sweet as possible. I also don't profess to be an IoT expert. I've only been in this industry for about 6 months. So I sincerely apologize if I'm not able to answer some of your questions, but rest assured, I will try my best. And though I'm not an expert, I'm definitely passionate about the field. Developments in the industry, come thick and fast, and they're, very vibrant. Just a few days ago, I was watching this live webinar from Dell. It was their IQT day. And yeah, that's right. They've already moved on to IQT, IQ being like, intelligence. And Dell sort of gamble or bet with this was that they're going to make a killing in the industry by moving computing power from the cloud and the data center to the edge, to the devices and the nodes where, there's a desperate need for computing power. And most importantly, I think we are all excited about the transformative potential that IoT has for the world. Just like how Dell has for this IQT concept. Okay, let's kick off then. So the first question, what are industrial IoT platforms? So industrial IoT platforms are software solutions that, monitor and manage connected devices. They help to store and analyze data. They automate workflows and, visualize systems for users from the shop floor to the top floor. So they may also include application development tools that enable end users to build very specialized solutions, tailored solutions. So there is no universal feature set or set of descriptions that describe IoT platforms. They specialize in a wide range of capabilities, and most IoT platforms operate in the cloud or on premise. And many, like I was talking about Dell, they offer edge computing capabilities. So what you guys need to understand is that IoT platforms in general, they offer certain advantages over a regular, custom built IoT system that's been put together from scratch. Industrial IoT platforms are faster. They're designed to handle industrial level data loads. They offer standardization. They're scalable. And of course, very importantly, they also tend to offer end-to-end data security across the stack. So next question. So why do companies deploy industrial IoT platforms? There are some very clear reasons for that. One of it, of course, is to overcome IT bottlenecks. So the key value proposition of IoT platforms is that they enable companies to develop and deploy IoT systems, without large teams of software developers, because that's the complicated part now, right? Today there are a few thousand IT companies that employ, teams of very specialized developers with the know-how to develop IoT systems. The vast majority of other companies, they lack this kind of sophisticated IT capabilities. So IoT platforms enable companies that are more technical from a wide range of industries like, manufacturing, energy, construction, you name it, to leverage their industry expertise to build solutions that better serve their clients and improve their operations. So in other words, the platform companies say, okay, leave the IT to us, we will kick butt in that department. You just bring the OT and the vertical expertise, the industry expertise, and it's meant to be like a symbiotic sort of a relationship, right? Okay, and IoT platforms also, they help to integrate with legacy infrastructure. So with IoT platforms, there's this notion of standardization as well. In a typical factory setting, there are so many devices from different companies and OEMs, and many of them are, old, clunky type of, war relic type machines that have been chugging away since the days of the, Lord knows, the Industrial Revolution. So how do you unify them, in a sense? If you're using a proprietary IoT system, then there's a pretty high chance that you're going to run into integration problems. And ultimately, this will adversely affect your time to market. So IoT platforms, on the other hand, they are built with certain, open global standards that bypass some of these integration problems. And of course, with IoT platforms, the most important thing is that they help businesses achieve with all kinds of use cases. All right, they come with development tools and enterprise applications that allow you to make business sense of the data. That's the most important thing. And then they allow you to add capabilities on top of your legacy infrastructure, your products, and your business models, and really like revolutionize them. Which is at the end of the day the most crucial thing. Okay, so now let's just have a quick look at the landscape of the IoT platforms, the market, the ecosystem, if you will. So there are more than 450 IoT platform companies in the market today, believe it or not, guys. And but the thing is that this number is expected to decrease. It's a competitive industry, and it's going to mature and consolidate. The IoT platform industry is highly fragmented, and only the top 7% of IoT platforms are actually earning more than 10 million US dollars in revenue in 2016. So you can see there's like this chunk of big companies, your traditional heavyweights, like you see in the slide over here, like your Cisco, your PTC, your SAP, GE, IBM. And then there's this very, long tail. You can see the graph stretching all the way to, so was also highlighted in the study that roughly 30% of all the platforms in the market were built specifically for the industrial or manufacturing sector. So these platforms often belong to traditional industrial automation and technology market leaders, such as you think your Bosch, your GE, your IBM, or to software companies like PTC and Microsoft. So initially, most of these IoT platforms tend to offer very horizontal solutions with very little differentiation. But now we're starting to see more and more segmentation. The industry is getting highly specialized into verticals, different industries. And as the market sort of consolidates, we will expect to see, a few, maybe 3 to 5 companies that dominate each niche. There'll be, other factors like economies of scale and monopoly factors that will also apply to IoT platforms. And the wide range of potential capabilities and use cases will likely prevent any single platform from dominating across industries. So this is just meant to give you a better idea of, how the IoT market is shaping up, IoT platform market rather. And here's another perspective or a take on IoT platforms, this time from a more technological maturity sort of standpoint. I'm using the Gartner hype cycle. It's a very popular sort of index to sort of present this. This is the most recent one, the 2017 one. So as you can see, the IoT platform, and in fact, a lot of other related IoT technologies, they are now in the peak of inflated expectations phase. And this stage is where, there's a lot of, media hype, and think about it, even today's presentation that I'm doing is sort of like a tiny sort of contribution to that hype, right? And the technology is, big, it's getting implemented. It's especially by early adopters. And there's a lot of publicity that's now coming out about, successful and unsuccessful implementations. But the thing is that we are also rapidly approaching the trough of disillusionment stage. This is the stage where the flaws and the failures of, IoT platforms start to, they lead to disappointment. People start to think, what, this IoT platform are not, what they're sort of cracked out to be. And, then there are, but then there will be continued investments in to sort of address these problems. And quite interestingly, there are some companies that are, mature and they're leading the industry. And I dare say that in terms of their technological maturity, I might even already put them in the trough of disillusionment stage. And they are already sort of moving towards the next stage, is the slope of enlightenment. And I'll give you an example using GE that I read a while ago to sort of back up what I meant. So essentially, what happened, I read about a few months ago, GE sort of called a timeout. And you can imagine how rare that is for a big, industrial automation, like an automation company like GE to do that. And it sort of coincided with with their ex CEO Jeff Immelt stepping down, retiring rather. And the reason for this, the reason why they call this timeout, it's not that Predix is bad technology. It's definitely a very good technology. It's just that there was some sort of missteps in terms of the strategy, of the platform, and that's why they had to call this timeout. And this sort of like fits in with this sort of notion that they were reaching this sort of stage where they were a little bit disappointed by the performance of GE. And long story short, the sort of pitfall that Predix was facing was that they were too horizontal. They were trying to, put their eggs in all, the IoT baskets, which we mentioned earlier, doesn't really work. So what GE is trying to do now, they're trying to have a bit of a strategic shift. They're trying to focus on some of their core industries, which are more heavy sort of industries, like, you think your energy or your heavy manufacturing type of industry. This is where GE has its sort of niche, and they're now trying to focus more on that. So that's how it's how it's shaping up across many companies in the in the industrial IoT platform market. This is just one example. Okay, so the next thing we're going to look at here is the types of industrial IoT platforms. So industrial IoT platforms, they're commonly segmented into three categories. You have the device management, the network management, and the application enablement and development platforms. However, the lines that sort of separate, these platform types are somewhat blurred. Some platforms, they want to differentiate by focusing more on certain specific capabilities or industries, and others will attempt to provide the most comprehensive solution, like, full stack in a sense, from the things, the endpoints all the way down to the apps and analytics. In fact, I'd say there's a fair amount that are actually quite full stack IoT platforms, especially the bigger ones. So typically all IoT platforms, they tend to include features such as user interface dashboards, reporting, security, and API compatibility. However, the sophistication of execution will differ greatly from, platform to platform. Nonetheless, this sort of segmenting, you can see these four sort of like boxes that I have with different labels on them. I think it's a very useful way to sort of visualize a typical IoT system and see what they're all about. And this will also allow us to sort of zoom in into like each one and see the scope of the different sort of segments. Okay, so first let me run through device management platforms and what exactly they are. So device management platforms, essentially, they allow for certain capabilities like provisioning. Provisioning is just, in case you're not so familiar, it's just a process of attaching a certificate or ID to a device to give it an identity, and then now it belongs to a network. They allow you to monitor, to manage, and to troubleshoot your endpoints or your things. And these things could be anything. It could be a robotic arm, it could be a wind turbine, it could be a sensor, an actuator, a PLC, you name it, a meter, whatever. And these platforms allow you to use your IT to access and control your OT. So some of the key features will include, like I mentioned, device provisioning, dynamic asset grouping, and like predictive maintenance. So for example, if the platform detects that an asset is close to failure from the kind of data it's receiving, it can send commands in the other direction back to the device to turn it off before, you get like catastrophic failure, and, or perhaps reroute traffic so that, you avoid costly downtime. So, and then, a little bit about, then the next phase you move into is like the connectivity phase. So you're talking about connectivity protocols. You're talking about, your edge devices, your gateways, like what I was talking about, Dell with the IQT sort of thing. Gateways are like the sort of like the middleman between the things and the cloud. They help to aggregate and process the data at the edge level before sending some of this useful data to the cloud. So, then you also have like network management platforms. And these, like, they help to orchestrate the IoT network, right? Manage your M2M data exchange between the edge tier nodes, the gateways, and the cloud. And these platforms ensure that your data is always available where and when you need it. So, like, key features include, like, traffic routing, risk and demand management, and multi-network communication support. And lastly, you move up the stack to the application enablement and development sort of platforms. And what they allow you to do is that they allow you to build IoT apps be it for internal use in your company, or to augment your product portfolio by quickly turning data into insight or action and visualizing it for users. So, these platforms, they offer templates, modules, certain, widget-based frameworks to create end-user applications. And some of the key features include your kind of typical enterprise sort of tools like your ERP, your SCADA, your your PLM, your product lifecycle management, and they are often like software development kits also integrated into these platforms. Okay, so now we come to this very busy looking slide. And what this slide is all about is about reference architectures. So, in the previous slide, we were talking more generically about how a typical IoT system is broken up into 4 segments. And this is definitely like basic IoT concept that everyone in the industry will know. Having said that, there is another important concept that's also known as reference architectures. So, in the IoT world, I'll be the first to admit, and I'm not the first actually, but I mean, standardization is not exactly one of our strong points. In terms of, be it the terminology that we use, the way things are represented. So certain authoritative organizations in the field, like the IIC, the Industrial Internet Consortium, they have come up with reference architectures that help to address this issue, of a lack of standardization, and they also act as a guide for other companies. So, sometimes it's not fully adhered to, but in general, most big IoT platforms and, big companies generally tend to conform with these standards, like the IIC RA. So let's take a look at GE Predicts again. Okay, you know what? Let's just focus our attention first on the bottom half of the slide, which is the IIC RA. So this is what we call this kind of a mapping is what we call a typical 3-tier architecture, and it's broken up into the edge tier, the platform tier, and the enterprise tier. And there are also different functional domains, which sort of explain like what exactly is happening in that sort of tier. And I'm just going to speed through this and just quickly walk you through it. First, you have the control domain, and the control domain is where, you're dealing with these edge nodes. These are your actual devices, your sensors, whatsoever. Then let's follow how the data often flows. It goes through a gateway. Like I mentioned, that this gateway is the one that sort of, aggregates and processes and does a bit of edge analytics over here. Sends the data then to the platform tier. The platform tier is like your middleman, between the devices and the cloud. So over here, slightly more complex processes take place. There's ingestion of your data and transformation, and there's also on the operations domain. You're talking about how they're, you're managing your assets from here. There are even APIs over here that allow, OT users. Like you can imagine, your floor manager, to directly access this tier as well. And then the data continues to move up the stack towards the enterprise tier. This is your, where you have your business domain, where you have all your different, like I mentioned, all the different sort of, enterprise applications, your CRM, your ERP, blah, 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 PLM. And you also have your application domain over here. This is where you have your logic and rules and where you have your API. So this will sort of present all of this, funky data in a very digestible way for the end user. And so I'm just going to quickly do what I did was that I just did a very simple I superimposed, if you will, a sample architecture of from GE. I think right about now you guys are thinking that I'm actually representing GE or something with the amount of examples I'm using from GE, but that's not the case. It's just that the Predicts has very open sort of good documentation online, so I was able to easily find information. So I'll just do a quick sort of mapping to show you how the flow is between like how a typical platform architecture is like. So again, like you have, your devices. Let's just say this is a wind turbine, a wind farm. So you have wind turbines over here. They send their data to Predicts' edge gateway, which is known as the Predicts machine. So this Predix machine will sort of churn through the data, and then it will send the data to the Predix cloud. And over in the Predix cloud, again, similar operations take place, sort of ingest the data and, orchestrate the network. And then the data will continue to flow down to all of Predix's apps, where, Predix, they offer, higher level sort of services like digital twin modeling, and they also have like a marketplace called Predix.io. It's for developers who want to develop apps on Predix to sort of go to. And you also have very intelligent and very user friendly dashboards that come out of this, so that people know how to manipulate the data. Okay, so moving on. Now we come to the topic about the maturity of use cases. So, you might be asking me, okay, Daniel, so you spend all this time yapping about, what IoT platforms are and how they work. But, what does my business stand to achieve from using them, So in order to find out more about that, we can look at the different IoT use cases and the maturity level of some of them. And this index it's quite a good index. It's done up by Bain. And it's quite comprehensive in terms of talking about how mature and attractive use cases are and what stage of development they are in, to sort of deliver on their promise. And you can see it's quite comprehensive. Most of the typical use cases are over here, but special attention to, like, predictive maintenance over here. Now, predictive maintenance is a bit of a, I guess you could say, a use case superstar, a bit of a poster boy for successful IoT implementation. A lot of companies are making a killing in the, with predictive maintenance solutions. So just be aware, folks, that, there are many use cases, out there, but you have to ask yourself, as a business, what I want to achieve and which use case is most applicable to me and how likely I am to achieve it, based on the current technology standards that exist in the market. So, so you can sort of tailor your expectations accordingly and know how to proceed. So that's, I guess, the main takeaway from this slide. Okay, so let's take it one step further now and really understand how businesses, real businesses are benefiting from, using these technologies. And the best way to do this would be to run you guys by certain case studies. So I picked these case studies according to demonstrate, examples of mature use cases and, case studies that I also think are quite interesting. So, okay, so the first one, so driving high performance with SAP Business Suite. So, this is an example with Mercedes AMG. It's a high performance division of Mercedes-Benz. AMG is, the one with the cool gull wing doors, the kind of car that I can only dream of driving. But okay, I'm getting a little bit sidetracked over here. So essentially, technicians need to test each engine individually as part of their rigorous, quality control and assurance protocol. But engine testing, however, is a costly and data intensive process. So engine failures also often occur within minutes of the start of the test, but they go undetected until the end. So the solution that Mercedes AMG sort of came up with was to sort of work with the SAP Active Global Support Organization. They're leveraging Leonardo, SAP's platform called Leonardo, that technology. And it's powered by SAP HANA. And HANA is Leonardo's cloud component. And they use sensor technology from another company called Modern Horsepower. So the operational impact that AMG sort of achieved from this is now they had one universal platform where all their engine testing and development data could be managed. And this increased process efficiency for them. More than 76% of their processes tested, showed marked improvements. Real-time status reports also enable remote diagnosis of the status of an engine. So this resulted in 25% faster run times on successful test drives due to real-time interruptions. So from this, just this one case study, you can see some key features of the platform and how it sort of benefited the business. You talk about like some things like the centralized, the compact nature of platforms. You talk about a clear demonstration of what we mean by predictive analytics, right? It's saving the company time and money. I mean, these AMG engines are beasts, and having them, malfunction, for the test can be a very costly endeavor. So I mean, do your testing, but save the engine before it gets completely toast. And all this real-time reporting and diagnostics also ensures that the quality is kept to a very high standard that Mercedes would expect. Okay, so here's another here this is I can't think of a clearer example to demonstrate remote access and control. I mean, if this doesn't show you, I don't know what does. I mean, and this is an out of this world case study. I mean, pun intended. Okay. And this is from Amazon Web Services, capturing NASA jet propulsion Mars Curiosity mission. Sorry. So the challenge here was that NASA's Jet Propulsion Laboratory, the JPL, they wanted to share the landing of a robot on Mars as part of their Curiosity mission with fans worldwide. And they had this enormous task of having to support hundreds of thousands of concurrent visitors to the website. And the NASA website also lacked significant live video sharing infrastructure. So the solution that they used was that they used Amazon Web Services to stream the images and the videos coming out of the Curiosity Mars landing machine using some of their key technologies like elastic load balancers. And the operational impact from this was that they allowed NASA to construct a robust, scalable web infrastructure in less than 3 weeks. And AWS's load balancing capability allowed for near real-time accessibility across multiple regions. And after Curiosity's landing, the mission also continued to rely on AWS to automate the analysis of images and metadata from Mars, as well as to communicate vital information and send commands to Curiosity. So, this case study is a really good example of how platforms have that ability to handle the pressures of, working with extreme conditions like distance and time, and even like, extreme, bandwidth conditions, in terms of not having their servers crash. Okay, and in the interest of time, I'm going to skip the next case study, even though it's quite interesting one on the Messiah volcano. But yes, and even environmental monitoring is another sort of use case, a less common one, but also a very interesting one. But I'm going to skip this for the interest of time. And I'm also going to quickly just breeze through this. Now that you have a better understanding of, what IoT platforms are, and, I'm going to just run you through some of the key factors that you need to keep into account if you want to sort of implement an IoT platform for your own business. So I'm just going to share some of the factors over here, 5 factors that will allow you to better evaluate between competing, alternative industrial IoT platforms. So one criteria is the data analytics. So just ensure that, the kind of analytics that the platform offers, is aligned to your business, Usually how this, they tend to work using algorithms, and how these algorithms work is that they're usually either rule-based. So, it's rule-based means, there's a human being who has a deep expertise on the topic who sort of manually codes out these algorithms. Or recently we talked about explosion of machine learning and, AI algorithms, So platforms do offer these type of things. Take into account what do you think will best serve your business. And another key feature, of course, is the ease of development. Many industrial IoT solutions these days, they are in the pilot phase, and they're intended to grow exponentially, both in terms of scale and capability. So it's important for you to, as a business, the ease of development is one of your key decision criteria, because it provides an indication of the cost required to scale or modify an IoT system. So take that in mind as well. Connectivity. We talk about in the IoT, you have a whole range of different devices. So you need to ensure that, that right connectivity protocols are in place. So take note what kind of connectivity protocols the platform supports. This is especially if you are a business that operates in a rather, sort of maybe remote regions where connectivity is poor, like at a, in an oil rig, or in maybe a desert setting, a wind farm or something. And then we talk about device management as well. Platforms, they vary greatly in terms of their ability to manage devices on the network. So some are, are designed like we went through earlier, specifically for managing at the device level. Others are more tailored for at the network, or the cloud level. So do also take note like how the platform is able to sort of manage devices. And the last thing, the most, and I think top on a lot of people's mind is, of course, your security, right? Your data security. I mean, and do we need another reminder? I mean, there have been so many high-profile cyber attacks in recent times. like the recent WannaCry ransomware attack that crippled, UK's and National Health Service, and a lot of car manufacturers as well. So definitely, security is a very key thing for your platform. And there are two major criteria that you can sort of check to ensure that your IoT platform will sort of be secure for your systems. One is auditing, ensure that your industrial IoT platform have auditing capabilities to detect vulnerabilities in your system, and that they are built in your security infrastructure for as well. And also in terms of identity, so for authentication purposes, your IIoT platform should be able to allocate a unique identity provisioning to a device. And this is often done through like certain technologies like public key infrastructure and trusted platform modules that we won't really go through today. Okay, so we're coming to the sort of like the last phase. And I thought what would be most useful or insightful for businesses would be to explain to you guys, or just provide you with some insights, into what you need to take into account when you want to implement a platform for your business. So the first insight is to ensure that you choose the right platform for you. And I know this sounds a little bit obvious, but let me explain a little more. Not all IoT platforms are made equal and for your industry. As I mentioned earlier, there's a trend of how these platforms are finding it difficult to compete horizontally, right? So find a platform that is for your niche and build from there. For example, if you are, an owner of a small F&B joint, using something like Predix or PTC's ThingWorks or even like Leonardo could be overkill for your case. So something, like, maybe Amazon Web Services or Oracle Cloud or even like Xively, could be more applicable in your case. And sometimes there are even like, geographic considerations. Like, for example, take where in let's say if your business has intentions to go to market in China, then you have to understand that like in China, public cloud is a bit of a thorny issue with the government. So you need to ensure that the platform that you're choosing has strategic partnerships with companies in China that allow them to operate in the Chinese market. In fact, recently, GE Predix and SAP HANA, they just signed IaaS partnerships and will be entering the Chinese market in 2018. So you have to be aware, do your homework about this kind of thing so that you're not stuck with a cloud provider that's restricted in China, for example, if you want to go to market in China. Okay, the next insight is to build with a business case in mind. So, there was a recent study that was put out by Emerson that found that there are 60% of industrial companies are actually pursuing IIoT pilot projects at the moment, but only 5% of them are investing against a clear business case. So, it does beg the question, is this just a bit of a jumping on the bandwagon kind of situation? Oh, my competitors are moving to IoT, so I'll also move to IoT. So the key is that you really need to know, what the business case you're looking at for your business. Yeah, I mean, the Internet of Things is all about the data, but it's about what the data is going to do to help you achieve, what you need. So, for example, if you need an asset tracking and monitoring solution, you need to ensure that your platform well, and if your platform will be able to help you achieve your business goals. And here's another thing. There was also another recent study that was conducted by IFS. IFS is a Swedish, they're like an enterprise software solution provider. They found that 84% of industrial companies are facing a bit of a disconnect. And the disconnect I'm talking about here is the one between data from connected devices and the strategic decision making and operations that take place in a company. So the point here is that this limits the digital transformation potential of IoT. So to move to the next level of digital, IT leaders, they need to bring their ERP environments into the IoT space, and you need to engage with the IoT data seriously. So, it's sort of like bridging the disconnect between the office, the corporate environment with the rugged environments of and the devices and the sensors out in the field, from plant floor to the C-suite. So the point I'm trying to drive here is that there has to be a very tight integration between the data that's coming out of your sensors and the applications that you run on your back end. And here's another thing for you all also to take into account. What is your development strategy? So, are you going for an, a organic bottom up approach? Are you going to build from the device up, or are you going to build from a top down approach, starting with your analytics and your enterprise applications, and then build out the platform features from the top down? Or are you going to adopt a partnership approach? And this is actually a quite an interesting one. For example, like, if your business, you could strike, alliances, with a big company, that could really help to accelerate your digitalization drive. So take, for example, a company like Schindler. So Schindler is like a Swiss manufacturer of elevators and escalators. And what happened recently was that they formed a partnership with Predix. So the advantage here is that Schindler gets in the fast lane towards their digital transformation of their equipment that's very, mechanical in nature, thanks to the Predix technology. And in return, Predix gets access to all this technical vertical expertise as well. So now Schindler becomes like the industry's like premier IoT enabled lift company, right? So it's quite interesting to see, the dynamics of the industry. How do other competitors like say like ThyssenKrupp, how do they react? Are they also forced to digitalize their products, and business models in order to stay competitive? These are things that are very interesting and kind of things that you should also be monitoring in your own industry. And of course, the last approach is M&A approach, which is to sort of like, maybe acquire a smaller, maybe a startup that's doing more niche IoT applications, which could benefit your business. And okay, the last insight I have is, okay, maybe perhaps a bit of a lame one, but just get started, and really, I mean, we spoke about the Gartner hype cycle and how we are now at the peak of inflated expectations with IoT platforms. But IoT has a lot of promise sometimes, and sometimes it lives up to that promise, sometimes it doesn't. But that's why it's imperative for your business to start now and start implementing maybe a trial project or something, because we know that IoT platforms are going to reach mainstream adoption by the early 2020s. So if you move now, if you start now, you will get first mover advantages in your industry. So that's the key thing. So that's pretty much the end of my presentation, but just allow me to do a little bit of maybe self-promotion over here. So I'm from IoT One, and IoT One essentially we are a information platform that acts as, and this information platform acts as a base upon which we provide a whole other range of services like lead generation and brand positioning and stuff like that. The point here I wanted to make was that if you're passionate about the IoT industry or IoT platforms, and you felt like you didn't understand what on earth this guy was going on about the past half an hour, then make IoT One your home. We are quite accessible. Here's the link to our site. In fact, we also recently did up a IoT platform review report. Here are the links to the report itself if you're interested to find out more. And lastly, this is just some of my contact details. I'm quite visible on LinkedIn, so do feel free to approach me to ask me more questions if you feel like this presentation you didn't get what you were looking for. So yeah, thanks guys. Okay, so now I will have a look at some of the questions. Okay, hi Janine. So you said only 5% of the companies have a business case, while the 60% are implementing. Okay. So let me clarify here. So yes, so the Emerson study that was performed, they found that 60% of IoT companies, not IoT, 60% of industrial companies are pursuing industrial IoT trial projects and stuff like that. But they found that only 5% of these companies they're actually investing against a business case. So in other words, what I mean is that only 5% of these companies are very clear about the kind of business case that they're trying to achieve. Do they want to achieve a predictive maintenance solution? Do they want to do you want to achieve energy management solution? And what Emerson found was that it's extremely crucial for companies to know what they want to achieve before diving into a IoT trial project, because it's not just about censoring up your whole factory floor. It's also about knowing what this data is going to help you achieve. that's pretty much it from my end. It's getting a little bit late over here in Shanghai. So guys, please just do get in touch with me on LinkedIn, or just send me an email or something if you want to follow up on any questions that you have. Simon, no, I am not on Twitter, unfortunately, Simon. So just do get in touch with me on LinkedIn. That'll be better. And yeah, okay. Thanks, guys.